Hello, energy enthusiasts and clean energy fans. Welcome to Trina Talks, where we have short conversations that speak volumes. I'm your host, Melissa Cavanaugh, head of marketing communications with Trinasolar. And on this episode of Trina Talks, I'll be joined by Mike Watson, who is the head of product for Trina Storage in North America. Mike oversees the regulatory compliance for Trina Storage in North America, and he's spent the majority of his career in regulatory compliance. He's a technical reviewer for national and international standards. He sits on multiple standard technical panels, and he's been with Trina for about 3 years and previously was with Mitsubishi Power Americas. And let me tell you, even if you have just a little bit of interest in energy battery storage and regulatory compliance and safety standards, which you probably should. I have a feeling that you're really going to enjoy this episode because Mike is here to talk about the results of the large scale fire test that was performed on Trina Storage's Elementa 2 container. But before we plug in to that fiery conversation, don't forget to hit the like button and subscribe for new episodes of Trina Talks that are released on the first Thursday of every month. Welcome to Trina Talks, Mike. I'm so glad to have you here.
Thank you. I appreciate it.
I know that we have something in common in that we both love to travel. Do you have anything interesting coming up?
Yeah, so I try to do a big trip every year. This year, we're going to do Italy. So that's the big one this year. Looking forward to it.
Wow. So what's involved in planning a trip like that?
So there's a running list of all the different countries around the world. And so we just kind of shuffle them and move them in terms of priority of what we want to see the most. And then we start knocking them off the list. So this year, Italy's at the top spot.
Well, I can't wait to hear all about it. Italy is definitely on our travel list too. Internationally, my number one spot is Switzerland. Have you been to Switzerland?
I have not been to Switzerland. I hear that it's beautiful, and I see things online that look absolutely amazing.
Yeah. I can't wait for that one. This year in 2026, our big travel is to Lake Tahoe. My daughter's getting married there. So have you ever been to Tahoe?
Oh, wow, wonderful. Yeah, so I've been to Reno. I was at a
Mhm.
job auditing a facility as when I was a regulatory compliance engineer. So I went up to Reno and I made sure to stop by Lake Tahoe to see it, and it's beautiful.
Yeah, we are looking forward to it. I have not spent time there other than driving through the area, but we're really looking forward to it. So let's dig into today's episode, where we are talking about the large scale fire test that you recently led and participated in for Trina Storage. And first off, for our viewers, why did Trina Storage just ignite an entire utility scale Elementa 2 Pro battery storage container? Why did that happen?
Yeah, so the new edition of NFPA 855 now requires large scale fire testing, as to where the previous edition didn't require it. It was just a methodology of going through stages, and we had we had made it to a stage where it didn't necessitate a large scale fire testing per the standard. But now the new standard just says, well, it doesn't matter. You have to do it, period. So that's why we did it.
So, what else is new in the standard that was requiring this fire testing?
Yeah, so, one of the things that's new, in addition to just saying that the test is required, is also necessitating what's called a registered design professional, an RDP, to not only review the test method and test setup, but also review the results. And so for us personally, and for me personally, I wanted to make sure that we looked at a partner and had a partner on board who has credibility, has a brand name that is recognized in this market, and that I have good relationship with. And so I chose Hiller Fire.
And Hiller is well known in our region, right?
Yeah, absolutely. And so, throughout my career, I've made lots of relationships and kind of aware of all of what I would say, the credible partners. So the same applies when we look for a PCS partner. We want to ensure that we do that proper validation, that they have, quality product or service, that they are credible, that they have history, whether it be PCS supplier or an EMS supplier, and the same is true with our vendors. And so when I saw the standard says you require an RDP, I said, okay, I vetted a few people. I said, okay, I know who I want to be our RDP, and that's who we went with.
Yeah, and what I have realized about Hiller during this fire testing process is that they really are the expert in that field. They've been around for a long time, and they're definitely well trusted and well known in the industry. So, Mike, tell us a little bit about the site and the details. How many people were there? Give us a little bit of an idea of what happened when you were on site for this test.
Yeah. So, I do want to mention that, NFPA 855 now requires large scale fire testing. It requires that it's performed by an NRTL. It requires that an RDP review the test method and review the results. The standard does not require that RDP show up on site and be there for the testing. It doesn't require that Trina necessarily be there or have our personnel travel there to be there. But we did all that. I wanted to ensure that we had subject matter experts on the ground, so that we have all eyes on this test for the best results possible. So because of that, to build credibility, we had, Hiller, we had them fly over and be there, present for the test. And I definitely said, I want to be there, boots on the ground for the test. And we had a whole fleet of Trina employees there. And again, we weren't required to, but we want to go above and beyond in terms of quality, and ensure that we have the best results.
So tell us a little bit about the testing setup, the layout, the design. What does a test of this magnitude detail?
Yeah, great question. So for the test setup, our product is a 20-foot shipping container, right? That's the size of it. And so let's say the cornerstone of this test is to ensure that thermal runaway does not propagate from an initiating container to an adjacent container. So what we had to do was set up a 20-foot shipping container, our product, fully populated, 100% charged, and initiate thermal runaway. And then also at the same time set up products surrounding it, behind it, adjacent, in front of it, and then see if that thermal runaway propagated to any of the additional containers.
Is there anything else about the test itself that you either think is interesting or you want to share with our audience?
Yeah, absolutely. In terms of the test setup itself, it was actually incredible because, a lot of these tests are done in a way that you need to collect the smoke, the off gas during the test. Mm-hmm. And there are different methods to do that. But for us specifically, our product, which is a 20-foot shipping container, and the adjacent containers were all underneath an enormous vent hood. And at the top of the vent hood, you had a 2.8 meter in diameter conduit that was not only collecting all of the off-gassing and the smoke, but attached to the other end of that conduit was two large industrial fans that were pulling air. So actually pulling all of the hydrocarbons coming off of the container. And then in addition to that, we had these skirts all around the perimeter of the vent hood that we were able to lower. So again, just in the event, if there were any wind or anything, that we can prevent, the smoke and the hydrocarbons from moving away and go straight up. We pull all of that information, all that data that we can analyze and see what's coming off of the containers as the test is in motion. And so in addition to that, we had heat flux sensors, we had, I don't know how many thermocouples. I mean, it was incredible. Many thermocouples, we had igniters. Part of the test requires that you ignite the off gas. So we had, not only we have an ignition system to ignite the off gas, we had a couple of different variations of technology to ignite the off gas, just in case one didn't work, right? And so we had, obviously, cameras, all around the perimeter. We had cameras inside the container. We had cameras inside the adjacent containers. We had drones flying around. We had a heat wall or a test wall set up with thermocouples on that. Let's see what else. We had thermal imaging cameras as well to capture thermal data for video, which was pretty amazing to see. So it just so much went into it. Again, it was a monumental effort, and it was great.
I do definitely get the idea of how much planning and work went into this, because not only were you following the guide and the standard for this test, but you were setting examples of areas where you could go above and beyond. And I know you are the first guest on Trina Talks to ever say ignite the off gas. That's the phrase that is probably going to stick with me. And I think that there's going to be a lot of viewers of Trina Talks who absolutely need and want more information about this test. So I hope that we'll be able to do a follow up about the results when they're ready.
Absolutely, be happy to do so.
So isn't it extremely difficult to set an Elementa on fire? How did you and how did the team initiate this fire and the thermal runaway? And then I have one last question, just because I'm really curious, of who got to push the button to start the fire?
Yeah, I'll start with that last question. I got to push the button. I thought it was amazing. I went all the way over there to be a part of it, to witness it, to make sure that the test setup was accurate. And so in addition to that, I said, hey guys, I want to be the one to push the button. And I did, and it was amazing. So for a technology and a chemistry like LFP, there's a higher threshold for starting thermal runaway. And so it is actually quite difficult. And through history and through previous tests that we've seen, there have been some companies where they couldn't even induce thermal runaway. And so once they said, hey, we can't induce thermal runaway, and they gave that to the NRTL or the AHJ said, not good enough. You have to induce thermal runaway so we can see the results. And so because of that, what Trina did is we had a primary module, and we had heating elements stuffed in between the cells. And then whenever we're ready to go, we push the button, and those heating elements will start heating at a rate of 5 degrees C per minute. And they'll just start heating and heating and heating and heating and heating until thermal runaway initiates. Now, if that doesn't happen, and it's a possibility that it doesn't happen, we have a second module, a backup module, that's also set up in the same fashion with heating modules. So if the first module didn't ignite or go into thermal runaway, we have a backup module. And then we went even further. If the backup module, the second module, didn't initiate thermal runaway, we had a third module where we opened up the face of the BMS and had a torch just pointed straight at it, so we can just blow a torch straight into the modules. But thankfully, we didn't have to use the second or third option. We just were patient and let the primary module do its job, and eventually it did go up. So that was the strategy.
Talking about the thermal runaway, what happened once that part was underway?
Yeah, so obviously it starts off a little slow, and then over time you start to see flames out of the top of the initiating container. One thing to point out that's important is, the test is performed with the deflagration panels open and the exhaust ventilation system open, meaning the inlet is open and the exhaust is open. Okay. And the reason why that is, and this is per the standard that those are opened, is it's to create more oxygen flow within the container so that you have more flame, more fire propagation, because we all know oxygen is fuel for fire. And so as we're watching it, we're witnessing it, flame starts coming out of one side where the initiating module was set up. And then over time, that flame starts getting larger and larger, and then it starts moving down. You can see it from quite a distance away, and you can hear it. You can feel it. Walk outside because we stayed a safe distance away, but it's a lot of energy being dispersed.
So you mentioned something that I think is really interesting, that the intake and the outtake vents were open. So you were creating a situation to encourage this thermal runaway, but for customers in a normal situation where there are batteries in use, that wouldn't be the case, right?
Correct. So depending on the independent products fire safety strategy, because there are some options in NFPA 855. And so not every container, let's say not every manufacturer's product is the same, right? So for us, what we did was considered worst case scenario with our design.
Right. So this should not be a surprise at this point of our conversation, but I do think we should talk about what were the results of the test. And I know that at the time of this recording, the official results have not been released, but could you share with us your overarching observation of the result of the test?
Yeah, absolutely. So the test and the results were phenomenal. The way that it handled the internal flames and fire and non-propagation of thermal runaway to adjacent containers was phenomenal. So on site, we had myself, we had TUV, and we had Hiller representatives. And afterwards, we went and we inspected, and we opened up the side door where the chiller was and where the backup battery is for the auxiliary power. And some components in there were actually still functional and still working post event. It was incredible. Everybody was kind of shocked. We looked at it, we're like, this is incredible that, not only did it do well in the overarching fundamental test of is it going to propagate thermal runaway, but there were actually functioning components still in operation afterwards. So it went wonderful. Couldn't have asked for more.
Yeah, it is. It's really unbelievable and remarkable how incredibly safe and secure the containers are. And after seeing the footage and hearing you talk about the safety features, but seeing the images and the videos of the flames of this test really just show how sturdy and resilient and most importantly, how safe the Elementa container is. So, what does it all mean? What do you think it means, not only for Trina Storage, but for the entire industry?
Yeah, it means confidence in safety. I was at a trade show last year, and there was a panel on stage, and somebody in the industry said something that really struck a chord with me. And they said, in this industry, a fire for one is a fire for all. So whatever happens to any of our products, it affects all of us, right? And so I'm happy to report that the results of our tests kind of builds that credibility, or adds to that credibility, that it can be a safe product under the right conditions and with the right manufacturing, with the right design, with the right quality, with the right team behind it. So I think that speaks volumes.
Right. And you just said something that reminded me, when we're talking about what you saw after the test, after it was completed, and there were elements that, were not even impacted by the fire. Can you talk about the containers that were next to the unit that was intentionally set on fire? Because I think that, most customers have any number of battery containers, right, in any project.
Mhm. Yeah, absolutely. So we could call those the target containers, right? So the one that we induce thermal runaway, that's the initiating container, and then the adjacent ones are the target containers. And so I'm glad you asked that question because during the test, you can see the flames coming out of the initiating container, and the flames were on the adjacent container on top of it. And I look over at my colleagues and like, oh yeah, this is normal. It's fine. It's okay per the standard because what it's doing is that flame is catching the paint on top of the adjacent container. The paint is catching on fire, and that's fine. It's just the thermal runaway can't propagate to the adjacent container. So I saw the flames and all that, and so afterwards we went and looked, and yes, the top for the adjacent containers, the top was charred. We opened up the doors to the adjacent containers and looked up, and it was amazing. Right? There's nothing. It was just like a functional, fully functional operational container. In addition to that, we checked the voltages on all the modules before the test for the adjacent containers, and then after the test, we went back and checked all the voltages again to compare to see did any of the modules lose charge. And again, they all held charge. There was no burning inside the container. There was practically nothing. It was incredible.
It's absolutely incredible. So I know that we are able to share some of the photos and the videos with our viewers right now, but we are going to put a link in the description to see the entire video that was produced of this fire test. It absolutely is something amazing to watch. And that's a little bit strange because usually when we are talking about energy storage, you don't want a fire conversation coming up. But in this case, this is really Trina Storage taking the lead in this fire test to not only provide the information to our customers, but more broadly across the industry. So, Mike, what is next for Trina Storage? What's on the horizon?
For right now, I'm going to run through the streets and show everybody the video and the report. I've already reviewed the official report. It's back with the NRTL for them to finalize it and close it out. And as soon as I get it in my hands, I'm going to show it to everybody and like a badge of honor, right? So,
Yeah.
first steps first is to get the message out there that we performed this test. It's completed. It went well. We have official word and documentation from the NRTL, from the RDP, and then also internally our own investigation. Now, for the future on the horizon, we have our next gen product, which is an Elementa Gen 3 with a higher capacity battery cell. So the product we just tested from large scale fire testing had a 314 ampere hour battery cell, and the Gen 3 will have a 587 ampere hour battery cell. But aside from that, pretty much all the things are the same in terms of the fire safety strategy. So prepping for that large scale fire test, sometime over the next 12 months will be, the next big milestone.
And I am sure that our customers and the entire industry in the United States, you are going to hear more and more about that Generation 3 Elementa 3 product coming from Trina Storage. So it's just nonstop innovation from Trina Storage at this point. It's absolutely amazing. Thank you so much for joining us on Trina Talks today. Do you have any final comments? Any other ideas you wanted to share before we wrap up?
No other comments necessarily, just that, I do appreciate all the support that went into not only the performance of this large scale fire test, but leading up to it, all the preparation that went into it, the people, the human capital, the resources, the travel that everybody, went to the actual test site and then stayed up all night for multiple days in a row. It was a monumental effort for many different people, and I just want to say how much I appreciate everybody that was involved in making this happen.
It sounds like it was all hands on deck. I hope that we can leave the open invitation for you to join us again on Trina Talks. I think maybe a part two where you and I can dive into the official results of the fire test.
Absolutely, be happy to do so.
Well, thank you again. We really appreciate it. And it has been a pleasure talking to you and jumping into this fire testing. You really kind of brought us into it and made us feel like we were right there with you while the containers ran into thermal runaway.
Thanks, Melissa.
All right. Thanks, Mike. As energy storage plays an increasingly important role in the renewable energy transition and in strengthening grid resilience, it is clear that Trina Storage and the Elementa 2 platform lead the way in best in class safety, performance, and value. If you'd like to learn more about the Elementa 2 platform, or if you would like to speak to a Trina Storage sales representative, follow the link in the description. And thank you for joining me on this episode of Trina Talks. Be sure to subscribe and share this video with your project team or anyone else who likes cool videos of big fires. Until next time, may your LCOS be low, your efficiency high, and your systems optimized. I'm Melissa Cavanaugh, and this is Trina Talks.